Hi, my name is James Cooper. I'm one of the software developers working on the Peachy printer. I'm working with Rylan here at Saskatoon TechWorks, and this is some of the stuff that we've been working on recently to try and make our printer better. What we've been working on the last week here is when we first did our prints, we found that some things were skew and warped and weren't really square like we would want them to be. And the other thing we found was that if we moved the laser too fast, we would get this really noticeable ringing in the output, and that's not very good for your prints as we're doing it. So there was those two major issues that we were trying to fix. And for the first one, what we did is I've got a couple different patterns you see there of drawing a circle and a square. And you can see that originally when we drew them, they were quite tilted to one side and not really round, not really square. And so we added calibration and translation setup to our output so that we could figure out exactly where the laser would go when we gave it a certain output from the audio jack and make sure that that maps to the position that we want it to go to. The other one for the ringing that we ran into was that the mirrors themselves naturally have a resonant frequency where if you're below that, they just move around slowly. Above that, they can't keep up. But at that very point, it will oscillate quite wildly and screw up your print. So what we did for that was, you can see I'm in the one of these, I'm sweeping across and changing the frequency of my output over time. And when I reach that point where it starts to resonate, the whole thing starts moving very wildly, and you can see that it gets very large. Our first approach to dealing with that is to use what's called a low-pass filter. And basically what that means is that for any of the frequencies that are higher than what we want, we filter those out, leave them aside, so that only the slower ones are there. Now you can see in the step response where we come up like this, and there's the ringing on that, when we apply this filter to it, the ringing portion goes away, but we do get a little bit of a time to get from the bottom to the top, and it is a bit rounded. And that is one of the things that you can't help but get when you filter it. So the next approaches we plan to take is to add dampening to our system by adding a little bit of friction in there so that it doesn't resonate on its own. And there are also other digital signal processing techniques we can use to not have to use as low of a low-pass filter, to have a faster filter that will compensate a bit more for that and allow us to make faster prints. So as part of this, one of the things this filtering enables us to do is to be able to move the laser very quickly around to avoid curing any of the resin as we're trying to make a rapid movement. And when we're trying to wait for the drips so that the level comes up to the right height and we can start the next layer, it's really important that we're able to move somewhere safe where we're not going to be interfering with our print, because right now we can't turn the laser off. And when we come back, we don't want it ringing all over the place and making a mess of the print, and that's exactly what was happening in the past. So as a result, we should be able to make much more complex objects that take a much longer time and get a very clean print on each of the layers. Having said that, we actually will be able to turn the laser on and off very soon, thanks to the circuitry that Scott is working on right now. In addition to that, we'll also be able to take care of another concern people have had, which is that a lot of sound cards are AC coupled and don't allow us to have these slow movements. And in order to help with that, Scott's currently working on an amplitude modulation circuit that should help us get around that issue. Now, all of the changes we've made just in the last week are really just the tip of the iceberg. We've come a long way already from having prints that don't really work all that well to something that is already quite usable at the moment, but there's a lot more improvement that we want to make, and that's exactly why we appreciate your support in helping us to do this additional development over the coming months.
I'd like to talk about just how young this printer is. There are so many improvements to come to get this printer what it can truly potentially do. And it's basically it's amazing that the printer was even able to print this small cube and the small trinkety little objects that we've done with it so far without having done any calibration or making up for any of the errors that are inherent in the design right now. So I'm really excited about what this printer is going to be able to do after we've improved it and we've had engineers thinking about how to correct for all the small problems that there are. Thank you so much, backers. It's been absolutely overwhelming how much positive support has been thrown at this project, and I just feel very grateful and humbled to be at the center of bringing this new technology into people's homes. I'm really looking forward to the continued conversation with thousands of people that have backed this project, and all the actual work that's being done by the community, even as we speak. It's just amazing to have this connection with the end user of the product before we've even produced it. It's an amazing opportunity, and I take it very seriously. Just please keep being very loud and boisterous in the forums. I'm all for free speech and strong opinions. And whether you're completely for what we're doing, or there's little pieces that you think should be done differently, or you think that we're just really messing up, just let us know, because when you let us know, that's exactly what we need to do to change, so that we can really match your needs.
Thank you, backers, for all of your support. We really appreciate it. And stay tuned, because we've got more updates coming for you.